All right, our book refers to these as constant velocity problems in the lines and planes section. So basically, we're going to use our understanding of vectors, our understanding of lines in space to answer these sorts of constant velocity problems. So basically, and this is an example straight out of the book, and I wanted to talk through it and help you understand what's happening. So it says a mermaid is initially at a particular point, and so notice they've got her underneath the water there. So there's her x-coordinate, her y-coordinate, and her z is -1. It says she swims at a velocity vector of this, that many meters per second. So she's traveling, she started at 15, and then she travels 3 units in the x direction. She goes in the -5 in the y, and then a -9/2 in the z. Okay, so sometimes that's helpful to write it this way instead. Okay, whatever. It says find the position after t seconds. Well, so this is going to mean, this is what we want to do is we want to write the equation of a line so that we can plug in any t value to figure out where she is at that time. So at x, her x, y, z will be equal to, well, where did she start? Plus at t seconds, I lied. So this is her velocity. So this is the position vector that got you to the line that she's traveling on, and this describes how she's moving up and down that line. So initially, when time is 0, she would be at this point, 15, 8, -1. When you plug in 1, then she would be, when t equals 1, she'd be at the point 15 plus 3 is 18. Let's hope I can add 3, and then this becomes, what is that, -2/2, and then, so -11/2. So she's 5.5 feet deep in the water 1 second in. Okay, so finding the speed, that's going to be the magnitude of this velocity vector. Okay, so we need to figure out, well, it's the square root of 9 plus 25 plus 81 over 4. Oh, goodness. I don't have a decent calculator at home. That's the challenge for me this coronavirus time, but okay. Do I have to do the math? This is 100 over 4. That's 36 over 4. Let's see if this works out nicely. 36 plus 100 plus 81 over 4. I don't know. Does it work out nicely? No, it ends in 7. Any nice perfect squares around there? Whatever. Keep going. Do the math. I could pull out my phone, but that just doesn't seem necessary. Okay, isn't that embarrassing that I don't want to add? I can do all the hard stuff. Anyway, it's fine. It's fine. I'm fine. Check the book. It's in the book. Okay, so it says find the time she reaches the depth of 28 meters. Okay, so when we think about depth, which value are we concerned about? Well, we're concerned about the z. And so we want to know, when does our z value here equal, well, do we want it to be 28, or do we want it to be -28? Well, a depth of 28 tells me that she's gone down into the water. And so we'll say, okay, so the z equation right up here, z is equal to -1 minus 9/2 t. We want to know when this depth is -28. Okay, so what does that add? 1, that's negative. Oh, this is nicer. Equals -9/2. That might have been nice. I just didn't feel like doing it. I'm so sorry. Multiply by the reciprocal. Multiply by the reciprocal. That goes in there 3 times. This means that t is equal to 6 seconds. So 6 seconds into her dive, she's now at a depth of 28 meters. I want to point out to you, so watch out, some of these problems, and I think this is kind of the point of number 5. So here, I think this is 5A in that section. It says, find the velocity vector parallel to this with the speed of that. Well, what we need to do is, if we're parallel, that means it's going to be k times this, right? Any scalar, any non-zero scalar. K not equal to 0. But this one, this 3, 4, so notice this is, I've gone over 4 and down 3, so this is that vector, where this is 4, this is -3. This is a 3, 4, 5 triangle. Life is good. But the magnitude of this is 5, which means its velocity is 5 kilometers per hour, or whatever my units are. They want it to be 150 instead of 5. So if what is that? 150 divided by 5 gives me 30. So I need a vector that's 30 times as long. Okay, so the answer to that would be 120, negative 90. So this vector right here, right? Did I multiply correctly? 12 and 9. Yes, okay, life is good. This vector should have a magnitude of 150, and it's parallel to the one that they gave us. So when they talk about, when you write the equation of a line, let's say that they started at the point 1, 2, and they wanted you to write the equation of this line, and they started at the point 1, 2, you can say, well, this line and this line those are the same two lines, okay? Because they're direction vectors, they start in the same position, their direction vectors are parallel to each other. But the advantage of this one right here is that it allows you to plug in the particular time because it's taking into consideration how fast they're moving. Okay, so while these give you the same equations of the line, or they're two equations of the same line, this one right here is more helpful in this particular problem because you could solve for lambda to figure out where they are at a particular time because it takes its speed into consideration. So hopefully that's helpful. Practice some problems. Fill out the Google form questionnaire if you have questions for me. And I miss you guys. I wish I could see you. This would be way more fun if we were together. But hopefully that was helpful. Let me know if I need to clarify anything. Work hard, practice.